Hi guys, so in this video we will be solving climb states with minimum moves problem. So let's first understand the problem. So the problem statement says that we will be given an integer n, that is the number of stairs, and we are initially at the 0th stair, that is we are standing somewhere over here. We are required to climb to the top of the stairs, that is we are required to climb to the top for the nth stair, and we have to tell the minimum number of jumps in which we can reach to the top of the stairs. Along with this, we are given an integer array where at each index it stores the number of allowed jumps from that particular stair. Okay, so suppose if at 2th location 4 is stored, that means that we are on the 2th stair, then we are allowed to take a jump of either 1 unit, 2 unit, 3 unit, or 4 unit. Okay, so if we are on the 2th stair, this is what at index number 4 represents. Okay, and if index number 3, suppose at index number 3 1 is written, then it means that if we are on index number 3, then we are allowed to take only jump of 1 unit. We cannot take jump of any unit higher than 1. Okay, so this is what this particular array indicates. Now we have to tell the minimum number of jumps via which we can reach from the 0th stair to the top of the stair, that is the nth stair. Okay, so I think the problem statement is clear to you guys. Now let's see how can we do this. Suppose I am on the 7th stair, or not 7th, suppose I am on the 6th stair, and this is down, this goes on down from 0th stair, it starts from 0th stair. If I'm on the 6th stair and I want to reach to the, this is 7th, 8th and 9th stair, how many options are available? Suppose that at index, this jump array, inside this jump array, at index number 6 2 is stored. Okay, that is I am allowed to take a jump of 2 unit. Okay, so I have two options. I can take a jump of 1 unit, I go to the 7th position. I can take a jump of 2 unit, I go to the 8th position. And I ask these two guys, what are the minimum number of ways to reach from you to the destination? We are using the same diagram like which we used in the earlier questions of this nature, that we are on the source, we want to go to the destination. There are substations in the middle, substation 1, 2 and 3. We directly cannot go to the destination since we are allowed to take a jump of some units which directly do not go to the destination. So wherever we can go, we will go to that particular location, and we will ask these guys how many ways, in how many ways you can go to the destination. Here we will ask what is the minimum number of ways from you to the destination. Suppose substation 1 tells us that from me, if you want to go to the destination, you will have to take 3 jumps. Okay, substation 2 tells that if you want to go from me, you will have to take 4 jumps, and substation 3 tells that if you want to go from me, you will have to take 8 jumps. Okay, and I can, using one jump, I can go to substation 1, substation 2, and using one jump I can go to substation 3 also. So which path will I choose? I will choose the minimum among these three. So I will use the substation 1 path. What I will do is that I am on the source, I will take a jump of 1 unit, I will go to substation 1, and from substation 1 I will take 3 jumps and I will go to the destination. So my final answer will be 3 plus 1, 4 jumps. Okay, instead of substation 1, if I would have chosen substation 2, then what would my path would have been? I will take one jump, I will go to substation 1, I will take 4 jumps, I will go to destination. In this case my answer will be what? 4 plus 1, that is 5, which is greater than 4 jumps, and I want minimum jumps, so I will not choose this path. So what I will do, that in whatever from taking whatever jumps I am allowed to take from the ith stair, I will take those jumps, and wherever I reach, I will ask those guys what are the minimum ways from you to reach the destination. These guys will tell me some number of ways, that minimum number of jumps from them to reach to the destination. I will take the minimum among all of these, and I will add 1 to it, because I need one jump from my current position to reach these guys. Okay, so I will add 1 to it. I will take the minimum of these and I will add 1 to it. So this is what we will be using to solve this problem. Okay, now let's see one example of how it is actually happening. Okay, suppose that I'm on the 6th stair. I can on 6th location 2 is stored, at 7th location 1 is stored, At 8th location also 1 is stored. At 9th location also 1 is stored. Okay. So from 7th, 8th, at 9th, no, 9th is not there since 9th is our destination point. So 9th is not there. For now, let's keep 9 as our destination point. So 9 will not be there. Okay. So now there are two options. I am on 6th position. So I can, on taking, if I take a jump of 1 unit, I reach to 7th position. Okay. If I take a jump of 1 unit, I reach to 8th position. Okay. Here you might be get confused that we are taking a jump of 2 unit, then why we are adding 1 to our answer. Yes, we are on 6, we are taking a jump of 2 unit to reach the 8, but the total number of jumps is only 1. We are taking only one jump. We are taking one jump of larger magnitude, but the total number of jumps is 1 only. Okay, right? That's why we are adding 1 to our answer. So what will happen over here is that I will take a jump of 1 unit, I will reach to 7th position. I will take a jump of 2 unit, I will reach to 8th position. Now I'll ask these guys how many ways are from there. From you, let's see that jump then. What is that jump? So that jump will be like, we will, from 6 we will take a jump of 2, we will reach to 8, and we will take a jump of 1 from 8 and we will reach to 9. So this was one option. In this, total jumps are what? 1 plus 1 is equal to 2. And another option was that from 6 we can take a jump to 7. From 7 again we will take a jump to 8, and from 8 again we will take a jump of 9. So in this case, total jump was 1 plus 1 plus 1 equal to 3. So we have to take the minimum one. So we will take 1 plus 1 second 2 units of jump case. We will take the case in which total 2 jumps are taken. Okay, that is, we will first take a jump of 2 unit, then a jump of 1 unit. So after seeing this example, many times a confusion occurs. What is that? What generally students think that we should always like take the jump of maximum magnitude. Like suppose if I'm on a state number 1 and jump of 1 unit is allowed, 2 unit is allowed, 3 unit is allowed, and 4 unit is allowed, then for minimum number of jumps we should always take the jump of the highest magnitude. Okay, but this is not always correct. Like this is not a correct solution. In many times we will get a wrong solution for this. Okay, if this was the correct approach, then we could have solved this problem in a greedy technique, but this is not a correct way. That is why, let me first show you example why this is not a correct way, and what is the correct way, and why we are using dynamic programming to solve this problem. Okay, suppose of this particular case, suppose that this is given to us like an array which represents the number of jumps which are allowed. Suppose at index number 1, give me a second, first let me make this array. Suppose at index number 1, we are at index number 1. At index number 1, 3 units of jump is allowed. Okay, and at index number 0, sorry, 0 1 2 3 4 5, and we want to reach to the destination point. Our destination is 6th. Okay, from index number 0, 3 units of jump is allowed. Okay, from index number 1, 5 unit of jump is allowed. Okay, and from index number 2, 3 4 and 5, at each of these locations only 1 unit of jump is allowed. So according to the largest magnitude jump, what we will do is that at index number 0, 1 unit jump is allowed, 2 unit jump is allowed, and 3 unit jump is allowed. We will take the maximum. If we take the maximum of this, then we will reach to index number 4. From index number 4, only 1 unit jump is allowed, so we will take 1 unit jump. We will reach to 5. From 5, only 1 unit jump is allowed, so we take a jump of 1 unit. We reach to 6. 6 is our destination. The total number of jumps in this case is 1 jump over here. The magnitude of jump is of 3 unit, but the total number of jumps is 1 only. Okay, so this is 1 jump, this is 1 jump, this is 1 jump, so total of 3 jumps. We are taking a total of 3 jumps in this case. If we go by largest jump, if we go by that particular order, we are getting 3 jumps, but this is not the correct way. That is what I am saying. Okay, now let's suppose think of second case. I take a jump of 1 unit, and I reached to index number 1. Okay, from index number 1, 5 unit jump is allowed. Okay, so from index number 1, I take a jump of 5 unit, and I reach to what? I do index number 1, I take a jump of 5 unit and I reach to 6th index. Okay, and 6 is my destination point. Okay, so in this case, total number of jumps, how many jumps I am taking? I am taking 1 plus 1 equal to 2. Total of 2 jumps only I am taking. So 2 is less than 3. So always taking the jump of highest magnitude is not the correct solution. Okay, so what we will have to do? So at each position, what we will do, whatever jumps are available to us, we will try all those jumps. Okay, and whichever of these gives, suppose this gives us answer number of x1 jumps, this gives us x2 jump, this gives us x3 jump, so we will take the minimum of x1 and x2 and x3. We will try all the 3 jumps or all the k jumps, and we will take the minimum among x1, x2 and x3, and I will add 1 to it as my answer. Our answer will be minimum of x1, x2 and x3, x1, x2 and x3. Our answer will be minimum of all these 3 plus 1, because the jump I am taking from here to reach x1, x2 and x3 or this substation, this one will be my jump which I have taken. So this will be my answer. Okay, so this is what we are going to use. Okay, now let's do one thing. Let's do a dry run. Okay, let's do a dry run on a sample case so that it will be more clear. Okay, now let's suppose that let me make 2 arrays. The first array is the jump array, which represents the number of jumps that are allowed from any given ith stair. Okay, make this quickly. Now the second one represents the minimum number of moves which I want from this to the destination point. Okay, give me a second. Okay, yeah, we are done with it. Let me 0, index 1, index 2, index 3, index 4, index 5, index 6, 0, index 1, index 2, 3, 4, 5, 6, 7. 7th is our destination point. Okay, we want to reach to the 7th position. Now suppose number of jumps here allowed are 2, 3, 1, 5, 4, 6, 7. Okay, now think of this case. I am on the destination point. I am on the destination point and I want to go to the destination point. I am already here. How many jumps will I have to take? 0 jumps. I'm already over there. I'm already present there. I don't have to take any jumps to reach the destination point. So for if I want to go to destination, from the destination point, the number of jumps which I want is 0. Okay, so for destination our answer will be 0. Okay, now let's try to find the answer for 6th position. Okay, now let's think 6th position can take a jump of 1 unit. I will reach to 7. Since 2 jumps are allowed, I can take a jump of 2 unit. I will reach to 8th position. But 8th position is exceeding the destination point. It is somewhere over here and I cannot take a jump in backward direction, so I will never be able to reach the destination. Okay, so I will not take this particular jump. I will take a jump only if I am reaching to the destination point or somewhere earlier, somewhere before the destination point. Okay, then only I will take a jump. Okay, so I will not take a jump of 2 unit. I will take a jump of 1 unit. 7 will return me 0. 0 jumps are required from 7. Okay, and 1 jump is required because I take a jump of 1 unit from 6 to reach the 7. So total jumps required from 6 to reach the destination point is 0 plus 1 is 1. So for 6, 1 jump is required to reach the destination point. Okay, now let's try to find the minimum jumps for 5th one. From 5th I can take only jump of 1 unit. Okay, so from 5th I can take only jump of 1 unit, so I will reach to the 6th point. Okay, from 6 how many jumps are required? 1 jumps. So my answer will be only 1 jump. My answer will be 1 plus 1. That is, there are no other options available for 5. So I cannot take minimum of 1 is only is 1 only. So my answer will be 1 jump that is required from the 6th point to reach the destination, plus this 1 jump which I am taking from 5th stair to reach to the 6th stair. That is, I am taking a jump of 1 unit. So 1 plus 1 equal to 2. That is, the minimum for 5 is 2. Okay. Now let's try to find the answer for 4th index. For 4th index, 3 jumps are allowed. Okay, so if I take a jump of 1 unit, I reach to the 5th position. If I take a jump of 2 unit, I reach to 6th position. If I take a jump of 3 unit, I reach to 7th position. 4 plus 3, 7th position. Okay, now from 5 tells us that 2 jumps will be required from me. 3 tells that 1 jump is required from me. 7 tells that 0 jump is required from me. So what I will do, I will take minimum of 2, 1 and 0. So minimum is what? So 0. And one jump is required from 4 to reach. If I am from 4, I need one jump to reach 5. I need one jump of 2 unit, one jump of 2 unit to reach 6, and one jump of 3 unit to reach 7. So total jumps required is in all the cases is only one. So my answer will be minimum plus one jump which I am taking over here, which I am taking over here. So my answer in this case will be 0 plus 1 equal to 1. So one jump is required from stair number 4 to reach the destination. Now let's also see what is that particular jump which I am taking. What is the minimum jumps? The options which are available are, let's see that in diagram. If I am on the 4th, this is 5th, 6th and 7th. One option which we are using currently is directly take a jump of 3 unit to reach to 7th position. So how many jumps are required? 1. That is what we are using over here. Another options are like we can take a jump of one from 4, we can take a jump of 1 unit to 5, and from 5 take 2 1 unit jumps and reach to 7. So in this case total there will be 3 jumps. We are not using this particular case. There is one more option that from 4 I can take a jump of, like from 4 I can take a jump of 2 unit directly reach to 6, and from 6 take 1 unit jump reach to 7. We are also not taking this case because here also we are requiring 2 jumps, and the minimum one is directly take a jump of 3 unit reach to 7. That is what we are using over here. Okay, I think this made the concept more clearer. Now let's analyze the answer for third. If I am on the third stair, 5 jumps are allowed to me. I take a jump of 1 unit, I reach to 4. I take a jump of 2 unit, I reach to 5. I take a jump of 3 unit, I reach to 6. I take a jump of 4 unit, I reach to 7. I take a jump of 5 unit, I reach to 8. I will not take this one because I am exceeding the destination. 4 tells me minimum one jump will be required from me. 5 tells that 2 will be required from me. 3 tells that 6 tells that 1 will be required from me. 7 tells that 0 will be required for me. My answer will be minimum of 1, 2, 1 and 0 plus 1. Minimum among all these 4 is 0. 0 plus 1 equal to 1. So for 3, if I am on stair 3, then I require only one jump to reach to the destination 7, and that jump is directly take a jump of 4 unit. Okay, let me show you that jump also, that if I am on third stair, I want to go to the 7th stair, then the jump which I am taking currently is directly take a jump of 4 unit and reach to the 7th stair. This is the jump which I am taking right now. Okay, so in this way we can fill this DP table from right to left. Okay, name of this array is DP array. Okay, now let's see what is stored at each location. At what is stored at index number 5. Index number 5, it is stored that minimum moves from stair number 5 to destination. At index number 3, what is stored? Minimum moves from stair number 3 to destination. Okay, so at 0, what will be stored? Minimum moves from 0 to destination. And what was asked in the question? It was asked to print the minimum moves from 0 to destination. This is what our question demands. So our answer is stored in the 0th location. So after filling this DP table, what we need to print? We need to print the answer whichever is stored in the DP of 0th position. That is what our answer will be. Okay, so I think I have made it clear to you guys. Now let's try to code this solution, and let's see whether whatever we have thought over here right now, or in this whatever intuition we developed, whether it is right or wrong. Let's try to see. Okay, let's try to code it now. So what we need to do is that let's scanner new scanner. Then it is told that we will be given an integer n. Let's take input for that integer. Okay, then we will given an integer array which represents the jump which we are allowed to take at any index. Let's take input for that. For integer I equal to 0, I is less than n, plus plus I. Let's take input array of I equal to scn next integer. Okay, and then we have to make our answer. We don't have to take any other thing in the input. No. Now let's an array dp in which we will store our answer. If we are on the destination point, then the number of jumps required to reach destination is 0. I've told you earlier also. Move from right to left. What we will do, we will check number of jumps. We will take all the jumps which are allowed at a particular location. We'll and find the minimum among those. Let's make a variable named answer. Let initialize it with maximum value. So what we are doing over here is that I have told you that at each location there will be, suppose if 3 jumps are allowed, we cannot say that whether minimum jump will give us answer or maximum jump will give us answer. I had given and you a test case. So what we will do is that we will, whatever jumps are allowed to us, we will take all those jumps, and I have told you that we need to take the minimum of all the options which we are getting, and we will add 1 to it. Okay, so what we are doing here is that we are iterating through all the jumps which are allowed at any given step. But I have also told you that not to take jump in which we are exceeding the destination. So if I am at index I am taking a jump of j unit, I will reach to index I plus j. Then I plus j is useful to me only if I plus j is less than or equal to n. Then only it is useful to me. If it is exceeding the destination, then it is not useful for me. So I will take a jump only if this condition satisfies. Otherwise, it will not. I will not take this jump. So I will add a check over here for this condition also. Okay. So let's add it, and then I am taking this answer variable. In this, I will store that. Suppose at any given location, if 3 jumps are allowed, so whatever answer I am getting from all these 3 locations, I will store the minimum of all these 3 in the answer variable. Okay, then I will store it in my dp array. In my dp, I will store answer plus 1 jump which I am taking from this position to reach all these positions. So I will store this in my answer array. Okay, now let's code it. So we need to write one more check over here, that if this jump is useful to me or not. Okay, so how will we write that? And if I plus of j is less than equal to n, then only I will take this jump. My answer will be minimum among all the answers, that is dp of a plus j. Finally, I will check if answer is not equal to integer, dp of I equal to answer. What I have written in this line, I am going to explain you just in a moment. Finally, when we are done, what we have to print is system.out.println dp of 0. This is what our answer is. First, let's check whether we have done everything correctly. We have taken input for n, we have taken input for array. Now we have initialized correctly. This is correct. This is correct. Good. So what we have done over here is that we wanted to take the minimum in the answer. So I have initialized answer with a very large value, that is infinity value, and I have assigned infinity to integer.max value. So what happens in Java is that there is a range of numbers. Okay, suppose the last value is integer.max value. Okay, and the least value is integer.min value. Okay, this is what the range of number is in Java. So if we add something to the integer.max value, this will become integer.min value. Okay, so if I directly add 1 to the answer, suppose if at current stair 0 jump is allowed. Okay, so there is no path from this particular stair to reach to the destination stair. So here integer.max value will be stored. Okay, since I am initializing my answer with integer.max value. Now if I add 1 to integer.max value, then integer.max value will become integer.min value, that is a very high negative value. So whenever I will take minimum, so my answer will become integer.min value. Okay, which is not a correct answer. That's why, to avoid this overflow, this condition, I'm using this check over here. Even if this is not a necessary condition, like you can use something like, instead of integer, if you don't want to write this particular line, if you don't want to, instead of initializing with integer dot max value, you can do something like that. You can initialize with integer dot max value -1, or you can initialize with it some other very high value, like some 10 to the power 4 or 10 to the power 5, which cannot be our answer. You can initialize answer with that value also, that will also work. Okay, so for now I have written it in this way. Okay, now let's is everything correct? Let's try to run it and see whether it is correct or not. Let's see, it is giving correct answer. Let's try to submit it. Let's see whether we are passing all the test cases or not. We are passing all the test cases. I hope you guys would have understood the solution.